Welcome everyone. My name is Piotr Kupisiewicz. I'm a tech engineer, or I'm part of the escalation team here in Europe. I'm supporting all different types of VPNs, FlexVPN, DMVPN, GetVPN, ASA, FTD, iOS, IOSXE, everything a part of the SD-WAN. When I was preparing for this session last week, I was wondering what would be my main question as Cisco customer when we are talking about VPNs. Because nowadays we are having SD-WAN, we are having iOS-based VPNs, we are having GetVPN, DMVPN, Flex, EasyVPN, CryptoMap, quite a few different VPNs. At the same time, we are having the firewall platforms like ASA and FTD. So which one should I use? The answer to this topic is not easy. Actually, last year here in Barcelona, I had a session about VPN overviews. I was discussing for 1.5 hours which different VPNs should be used in which use cases. This session is about FlexVPN, but I will still try to answer the question on which VPN should be used maybe in 1 minute. So in my view, when we are talking about ASA and FTD firewalls, these are really great devices for remote access. If you want to terminate any connect sessions on some device, FTD and ASA will do really well. These devices support remote access really perfectly. When we are talking about site-to-site and ASA and FTD, I'm from TAC, and this won't be a marketing session. I will tell you how I see things as a technical guy. From TAC perspective, ASA and FTD are far from being perfect on the site-to-site VPNs world. I would not recommend to go ASA, FTD in the high scale. So if you need to terminate 5, 10 tunnels, site-to-site tunnels, and you have ASA and FTD, you don't want to buy and operate the second device, go ahead with ASA and FTD. There's no problem with that. But if you are thinking about 1,000, 2,000, 8,000 branches, I would not consider ASA, FTD. I would more go into different flavors of solutions. So what are these different types of solutions? SD-WAN, if you are having Cisco devices, if you are having IOSXE-based devices, so quite modern routers, if you want to manage your VPNs and your network centrally from vManage, if you don't really want to make any customizations, yeah, SD-WAN is really great solution for you. If you are having third-party devices, if you want to go really high scale, 300,000 branches, but maybe even 5,000 branches, you want a customization, you want a good integration with AAA, FlexVPN is a solution for you. This would be my answer in 1 minute. So today we will talk about FlexVPN. As you can see, I think it really has its place in the portfolio, even when we are having SD-WAN solution, so ex-Viptela solution alongside. A little bit about me. I already mentioned I'm from TAC, but at the same time, I'm from Poland, so this is where I'm working. You can probably hear it based on my accent. What you might know about Poland, we eat a lot of cabbage. Actually, everyone who comes to Poland says we eat only cabbage. And there is also quite famous liquor from Poland that you might have heard of. What we will talk about today. I already mentioned FlexVPN. This is advanced session, 3,000 session, but I will still start from zero, so we will do a FlexVPN in a nutshell. So very short introduction into FlexVPN. We will very fastly go into more advanced designs, hub and spoke, dynamic mesh. We will add MPLS on top of it. We will talk about different high availability scenario with routing protocols, without routing protocols, zero-touch deployment. So how do you deploy 2,000 branches? Maybe you don't want to pre-configure them. How are we proposing to do that with FlexVPN? With that, we will close the site-to-site VPNs. We will go more into remote access, so AAA integration, radius integration, and at the end of the day, I will show you that site-to-site VPNs and remote access in FlexVPN are so close that it's actually very difficult even to draw a line. What is a remote access VPN? What is a site-to-site VPN? So this is the agenda that I've prepared for today. I hope you will enjoy it. It's really aimed for technical audience, but not only for the network architects. If you are wondering what capabilities FlexVPN provides to you, this is what we will be discussing in next 2 hours. I have a couple of demos, so this session won't be just slides, live demos. So let's hope they will work. Recently, I'm not super lucky. Like 50% is the success rate. Let's see how it will be today. There's really great book about IKE version 2. written by two of my colleagues, Graham and Amjad. They are actually part of the FlexVPN team. We are working very closely with them. I have one of these, as you can see here, and I will give this book away during this session. I will ask one question, and for the first proper answer, I will give this book away to you. On the logistics, we are having WebEx Teams opened. It was opened already for a couple of weeks before the session. During the session, feel free to ask questions directly to me. If you could please raise your hand, and I will try to answer your question. At the same time, you can ask the questions in the WebEx Teams. I have two of my colleagues, Wen Zhang from US TAC, from the escalation team, and Frederic Detienne, main architect of FlexVPN. We sometimes call it FredVPN because of Frederic. So both of them are with us in the Cisco WebEx Teams. They will also answer your questions if you have any. At the same time, I will be available after the session as well in the room, so we can have some offline discussion. So let's go into the meat of today's presentation, key platforms that FlexVPN runs on. These are routers, iOS and iOS-XE based routers. So ASR1K, CSR1000, ISRs, 800, 1100, 4000. So only routers, iOS Classic and iOS-XE based routers. Does it mean, is FlexVPN supported on ASA or on FTD? No, but it will work fine with ASA or FTD. So you can have a FlexVPN on one side, and on the remote end you can have ASA or FTD, or even you can have a third party, because FlexVPN is standard based. We are using in FlexVPN IKE version 2. You cannot use IKE version 1 when we are talking about FlexVPN, and you need to have an encryption enabled. So DMVPN, for instance, can work without encryption. You can have pure GRE based DMVPN, and you can use something else for encryption, like GetVPN if you want. With FlexVPN, you need to use today IKE version 2, and encryption is mandatory, and routers only. Where do we use FlexVPN? We actually use it quite extensively in Cisco, which actually I think speaks for itself. We use it in Umbrella, for instance. We use it in CWS, so Cloud Web Security, although this product is currently EOL'd, but Umbrella, which is the replacement, also uses FlexVPN. We have a lot of customers in the big thousands of deployments. The biggest deployments of FlexVPN will be in 100,000 of branches. I cannot name here the companies. I didn't have a permission, but we have a deployments of 400,000 branches that are using FlexVPN, so massive FlexVPN deployments. So the technology is really, really super active. It's alive, because this is a question I'm getting. Hey, Piotr, SD1 is coming in. What will happen with FlexVPN? It's really alive. As I mentioned at the very beginning, SD1 has a little bit different positioning in my view. FlexVPN has its place in the market, clearly. So fast recap. This is fully working FlexVPN configuration. Fully meaning you copy-paste this configuration into your two routers and it will work. We are using here on the overlay the network 172.16.1.1, which is simulating underlay network, very popular. Most probably in most of the deployments, this will be an internet subnet. On the LAN sites of both ends, we are having IPv6. This is just to show off, to show that FlexVPN can do IPv6 over IPv4. It can do dual stack. It can go. If you are migrating into IPv6, FlexVPN is IPv6 ready fully. So fully working configuration. Let's zoom in a little bit. Let's look into the components of FlexVPN. Heart of FlexVPN is IKE version 2 profile. This is the first component that you are seeing on both ends, on both routers. Let me try to use the marker. Yeah, this is the main component that we are having, IKE version 2 profile. We are having the first thing that we are having configured in IKE version 2 profile is identity. We need to configure on both routers how the routers will introduce themselves to the remote end. You configure it with an identity local keyword. This is the keyword here. And you need to now match this identity on the remote end. So one router needs to be configured on how it will introduce itself, and remote router needs to be configured on what identity it will expect. So these values, they need to be cross-configured. They need to cross-match, right? Later on, you are configuring authentication. So how do you want the peers or the routers to authenticate each other? You can use pre-shared key, you can use certificates, you can use IP. We will talk about it a lot in next 111 minutes. Once you configure authentication and you finish the Ike version 2 profile, you need to configure tunnel interfaces. This is mandatory in FlexVPN. So here we are having tunnel 0 interfaces, and we are having OSPF running on top of it to exchange the routes, to exchange the IPv6 prefixes. And this is fully working Ike version 2 FlexVPN configuration. To zoom in, this is an advanced session, so we will really go into some of the details of FlexVPN. To zoom in, Ike version 2 profile. This is full CLI that Ike version 2 profile allows you to, this is everything that you can configure. So in the first part, you can see here, we can configure identity. There are multiple types of identity, so you can introduce, you can configure different types on how the router will introduce itself. It can use IP address, it can use key ID, it can use email, it can use DN. There are quite a few different properties that you can use. We will use them later on during the session. There are corresponding match identity CLIs, so to match the identities that you just configured. Later on, there is authentication part. I already mentioned you can use pre-shared key, you can use certificates, you can use IP. What is maybe worth underlining, in Ike version 2 you can have asymmetric authentication. It's a little different than in Ike version 1. So you can configure one side to use pre-shared key to authenticate itself, and the remote side might use certificates. So you might have asymmetric authentication, quite unique property of Ike version 2 as a protocol. So this is profile, the Ike version 2 profile. If we are talking about identity, this is how it looks at the packet level. Third packet of Ike version 2 exchange, Ike auth, it will contain the field which is called identity. This is the field that you configure here with this identity local command. So this is where it lands in your packet. If you are using certificates, the certificate will be here, and this is how you match now. So you can match the identity using the match identity keywords. And if you don't want to match based on identity, you can match based on the certificate itself. It has nice property because identity by itself is not cryptographically signed. I mean, if you are having a router which is called Warsaw, theoretically a potential attacker who compromised such router could change it to Krakow, for instance, or to Berlin or to Barcelona, right, to different city name. And then if you are applying policies based on this ID, this might be tricky. I mean, it is not signed in any way. If you are using certificate is signed. So it's probably more secure if you are not having super big trust in your remote branches. If you don't have a physical security control in your remote branches, certificate is probably better field to match against. There are a couple of additional CLIs that you can configure. I said can because you remember these parameters. I mean, you could have noticed that these parameters were not shown on the first slide, and I said this is full FlexVPN configuration. There are still parameters like phase 1 proposals, so phase 1 parameters, authentication or integrity algorithms, encryption algorithms for phase 1. These are optional, so you don't need to configure them. We introduced what we are calling smart defaults, so the parameters which are defaults, they are there. We think that they are providing really good level of security, enterprise level of security. They are there. You can use them. If you don't want to use them, you can remove them, you can change them, but the defaults are there. So if you don't want to be bothered, if you want your configuration to be smaller, or you just want to trust us on what secure parameters are there at the moment, you should use smart defaults. 2 years ago or 3 years ago on this slide, for instance, we have a Diffie-Hellman group 19 and 14 nowadays as a default. 2 or 3 years ago, we had Diffie-Hellman group 5 and 2. So we are evolving the parameters. We are changing the defaults to make, to catch up with the recent security recommendations. So smart defaults for phase 1. We also have phase 2 parameters, so how the actual data will be encrypted, what will be the encryption algorithm, what will be the authentication algorithm. We have a defaults for that as well that you might want to configure, or you can again use the smart defaults that we are having. So this is fast FlexVPN recap. Are there any questions at this point? Sorry, could you repeat? So the question is about authorization profile. I will park this question. We will talk about authorization profile in 50 minutes, really extensively in the AAA part. So we talked a little bit about, we talked about IKE version 2 CLI, but FlexVPN is IKE version 2 profile. This is a hard and tunnel interfaces. This is the second part of FlexVPN. So how tunnel interfaces work? First, let's maybe do a step back and let's look at the router, how router works for the regular clear text traffic, for non-encrypted traffic. When there is a packet coming into the router, regular clear text packet, what the router is doing, it is applying input features first, like for instance, incoming or inbound access list, just to verify if the traffic is allowed to go into this router. Then routing is making routing decision. It is determining the egress interface, the output interface, and it is applying outgoing or output features on this packet. So this is at the high level how a router works for the clear text packets. Now, how does the router work for the encrypted packets, and how does the tunnel interface work? This is quite different versus CryptoMap that most of you might know. I know CryptoMaps were really popular. By the way, maybe it's a short remark. In Cisco internally, we are treating CryptoMap as a little bit legacy. So we are recommending our customers. I don't know if this message is passed, clear enough. I would like to underline it and reinforce the message. We are treating CryptoMap as legacy. We are recommending our customers to go to tunnel interfaces, so to exactly what I'm about to talk about. There are a lot of, the answer why is probably much longer, but in short, there are some scaling limitations that are related to CryptoMaps that are being addressed in the tunnel interfaces. So tunnel interfaces should be the technology that you should consider strongly versus CryptoMap. And CryptoMaps, especially in iOS XE boxes, especially in the big scale, should not be used. This is TAC recommendation, right? So tunnel interfaces. We are having our clear text packet coming in, input features, routing decision, but this time routing decision, we are talking about packet to be encrypted. It's not, the routing decision is not pointing anymore at the physical interface, it is pointing at the logical interface, at the tunnel interface. So the routing is telling we should use tunnel 0, tunnel 1, tunnel 2. And then the packet is being encapsulated based on the configuration of specific tunnel. Another routing decision after the packet is being encrypted, and we are ready to send the packet outside. So we are doing 2 routing decisions, but it has big advantage. We are applying output features of a tunnel interface itself. So if you are, and this is a very unique property of FlexVPN. In FlexVPN, we are using only point-to-point interfaces. If you are familiar with DMVPN, for instance, or with CryptoMaps, in DMVPN we are using what we are calling multi-point GRE tunnel interfaces. What it means and what is the advantage of point-to-point interfaces is that you can configure, for instance, QoS or access list, but per tunnel. So if you are having 2,000 different tunnels, you can configure parameters which are specific per different tunnel. MTU, which is different per tunnel, zone-based firewall zone, access list, QoS, everything that you can, or most of the features that you can imagine per tunnel. It is impossible to be achieved with DMVPN or with CryptoMap, because then you are having one tunnel interface which is sharing the output features. All of your VPN tunnels in DMVPN, if you have 4,000, 8,000 tunnels in DMVPN, they will share the configuration of one single logical tunnel interface. So no possibility of achieving per tunnel features. It is possible when you are using point-to-point tunnel interfaces, which we are using in FlexVPN. We are having 2 types of interfaces. We are having static tunnel interfaces, where you pre-configure everything, source, destination, all the parameters, but we are also having dynamic point-to-point virtual interfaces. We call them DVTI interfaces. Dynamic interfaces in FlexVPN allow you to achieve per tunnel parameters, or per group of users, or per user parameters. So this is a use case that you can consider. You are having a mobile devices or mobile users. They are connecting into your FlexVPN server. You are applying to this user specific policy. Access list, which is specific to or relevant only to mobile users. VRF, which is relevant only to mobile users. QoS for the mobile users only. There might be different policy that you are applying to different type of users. Let's call them travelers who are using regular desktops. You might apply different QoS policy, different access list, different VRF for those. And the same for instance, physical routers that are connecting. Yeah? You might want to assign 1 megabit for one user who is connecting from home, but if it is whole branch, you might want to assign 100 megabit in the QoS policy, because this is a different type of VPN connection. This is what you can achieve with dynamic virtual templates and with point-to-point interfaces. And this is what we will talk about today. And this can be achieved only with FlexVPN. How do we create virtual tunnel interfaces or dynamic virtual tunnel interfaces? When there is an IK connection, so when there is a branch connecting during the IK, so the control plane, in the configuration, from the configuration of the router derives the fact that we should use the virtual tunnel interface. It takes a template. There is a template that is being pre-configured. It takes this template and it creates an instance of a template that is being applied for that specific VPN connection. And this is how it is being done. So on the router, you are having only template configured, very small configuration, and you can terminate up to 10,000 VPN connection with 20 lines of configuration on your hub. This is the dynamic tunnel interface. This is what dynamic tunnel interfaces provide. IPv6 support. I already mentioned this at the very beginning. Long story short, we support all different mixes of IPv6 and IPv4 deployments. We also support dual stack or mixed mode in GRE if you want to use both IPv4 and IPv6 at the same time. If you are using IPv6 or if you are in the middle of the migration from IPv4 to IPv6 and this migration never ends, right? It lasts 20 years. In the past, you needed to configure virtual templates and the tunnel mode, and you needed to predefine in your template what will be the connection type. Will you use IPv6 over IPv4, IPv4 over IPv6? And long story short, you needed to have a couple of templates. If you had a different type of users connecting, some IPv4, some IPv6, you needed to have multiple virtual templates. We decided to simplify it. We introduced a feature which we are calling, how do we call it? Auto tunnel mode, which allows the router to determine automatically what should be the tunnel mode. So you are having now one virtual template. You are saying tunnel mode should be determined automatically, and whoever connects, is it IPv4 or over IPv6, basically the client will determine what type of tunnel we should use, what encapsulation should be used. Voila, we went through the introduction, yes?
A question in regards to that auto tunnel mode, how it applies to the profile where you actually for IPsec you would use a different, probably use tunnel mode, and for GRE you would use transparent mode, right? So how it applies, how it would apply
So the question is about GRE and regular IPsec mode, and for GRE we are using transport mode, for IPsec we are using tunnel mode. So yes, this will be handled by by this mode. Basically the client, so on the spoke, if you will configure GRE with transport mode, this is what the branch will suggest to the hub. It will say, I would like to use GRE and transport mode, and the code of tunnel mode auto will say, okay, I agree, and it will just reflect and mirror the
second line, tunnel protection IPsec profile default. So default is enabled to the profile.
This line here.
You would actually you would need two profiles for tunnel mode and transparent.
So the question or the comment is that we are using one IPsec profile with a name default here. The fact is that the tunnel mode auto, it overrides what you are having configured in your profile. So if you are having the mode tunnel, it will be overridden by the auto logic. And the same with tunnel mode GRE, it will be also overridden by the auto. Any more questions on what we covered till now? Comments? Okay. Hub and spoke and dynamic mesh. So hub and spoke in FlexVPN, everywhere we are using point-to-point interfaces. Towards the hubs from our branches, we will use static tunnel interfaces. So on the branches, you will configure what is the IP address of your hub or hubs if you are having multiple of them. But if you want to build and if you want to configure dynamic mesh, so you would like the spoke-to-spoke communication to work directly without involving hub, you can do it, and we are still using point-to-point interfaces, but these interfaces are being created dynamically and on demand. So if you need them, we are establishing the site-to-site VPN between the branches. If you don't need them, or you needed them for your network needed them for some time, the tunnels are built, but then they are not being rekeyed, and we are basically terminating these tunnels if they are not longer used. So dynamic mesh. Super efficient if you are having especially smaller branches which are unable to handle thousands of IPsec sessions. You want them to handle only, you want the small branches to have the tunnels up only when there is such need. So the dynamic mesh is super efficient from this perspective. So how does it work, or what is the simplest design in FlexVPN when we are talking about hub and spoke? In IKE version 2 as a protocol, we are having something which we are calling config exchange. You might be familiar with it. In IKE version 1, we also had something similar. There was a similar concept to config exchange. It allows to exchange the data at the IKE level, at the control plane level. So what is the example, or what is the use case for it? When there is an IKE negotiation, spoke upon to connection to the hub might request some information from the hub. It might say, spoke might say in the IKE exchange itself, hey, what are the networks that are being protected by you? What are the prefixes that I should insert into my routing table? So this is this config request that is being here. What networks are you protecting? And what hub might decide to do, it might decide to respond to such requests and say, these are the networks that I'm protecting. 192.168.0.0/16, which is summary route for all the networks that are behind the hub and are behind all the other branches. And this information will be sent in the config exchange. So no need of routing protocol. You can actually do what routing protocols are normally doing inside of the IKE exchange. So no more additional routing protocol to manage, no more keep alives. You can do it in IKE. Very easy and very light solution, very nice, especially for IoT deployments, where you don't want to send keep alives too often, or routing protocol keep alives. Disadvantage of it is that this is static. So upon the connection, both devices, they exchange the networks that they are protecting. But if something changes on the way, for instance, one of the devices stops protecting specific network, in IKE, there is no way today of performing an update, like dynamically. The update would be done only when the tunnel reconnects. So when the tunnel is up, you cannot perform any modifications of routing table today. So the question is, how do you see these routes which are being exchanged? These routes are being inserted as a static routes. So you will see them in show IP route. And by the way, the routes might be exchanged from the hub to the spoke, but also vice versa. Spoke might inform the hub what are the networks behind the spoke itself. So it works in both directions. Yeah? In IKE itself. We call it IKE version 2 config exchange or IKE version 2 routing, because we are exchanging routes. So how does it work in the hub and spoke deployment, on how dynamic mesh in general works in FlexVPN? We are building between the hubs, if you are having more than one, and normally you will have more than one. Similarly to what we did in DMVPN, you are building a tunnel interface. It doesn't need to be protected. It might be a regular GRE tunnel if your devices are in the same subnet, for instance, in the same data center, in the same building, for instance, and you don't need to encrypt it. Spokes connect. On our hub, we are having virtual access interfaces created. So these are these dynamic interfaces that are being built from a template. So the spoke 1 connects. There is a new interface created on the hub 1. The routing is being populated because the spoke in the config exchange, it instructed the hub, hey, 192.168.1.0 is the network that I'm protecting. So the hub will insert this route pointing to the virtual access, to dynamically created interface that we just created. The spoke will have a tunnel 0, so the static interface configured, but it will also dynamically insert the network, the prefix into the routing table pointing to the hub, 192.168.0.0/16. Now when the second spoke connects, the same happens. On the second hub, we are having the virtual access interface being created, config exchange or config routing, version 2 routing, and we are having the routing tables being populated. No routing protocol here. Now, if the traffic starts to flow between the devices, let's say the spoke 1 wants to send, the host behind spoke 1 wants to send the data to the host behind spoke 2. The routing decision is being done on spoke 1. The traffic is being sent to hub 1. Hub 1 does the route lookup. It will determine the next hop as a tunnel 100. And because, and this is very similar to what you might know from DMVPN, because the hub is forwarding the traffic from one tunnel interface to another with the same NHRP network ID, this is a part of the configuration I will show you in a moment, but because basically the hub is forwarding the traffic from one tunnel interface to another, it will guess that there is a better path or more optimal path for this traffic. And it will inform the spoke that, hey, I will accept this packet and I will accept this traffic, but for your information, there is probably a better path. And this is the packet that is informing the spoke that there is probably a better path. We are calling it NHRP redirect or a traffic indication. Very similar to what we do in DMVPN. Still, the packet is being forwarded to hub 2 and then it's being forwarded to spoke 2, so the traffic still works, but it goes initially through the hub. Now, because our spoke 1 received the traffic indication or NHRP redirect, it is saying, okay, I was informed that there is a better path. Let me ask what is the better path. So now it will send a resolution request, NHRP resolution request, based on its routing table to hub 1. Hub 1, based on the routing table, will forward it to hub 2, and hub 2 will forward this resolution request, it's a control plane packet, to spoke 2. Spoke 2, upon receiving resolution request, it will do a route lookup, and it will determine that the exit interface for this question, because the question is about what is the better path for 192.168.2.2, the spoke 2 will say, okay, my routing is pointing to Ethernet. So it's not FlexVPN tunnel interface anymore, so probably I'm the exit host for this question, so for this resolution request. I'm the exit node. So it will decide to answer this, to answer the resolution request, not forward anymore, but to answer. The NHRP resolution request contains all the information about the originator of the request. So the packet itself will contain public IP address, internet IP address, on NBMA IP address, we call it differently, of spoke 1. And because of that, now spoke 2 is able to, using this information from an NHRP resolution request, to respond, establish VPN tunnel, establish first version 2 control plane and then IPsec SA, and inside of this tunnel, newly and dynamically created, it will respond. The question was about 192.168.2.2. What is the better path for this host? But in the answer, the spoke 2 will say, you ask about host 192.168.2.2, but I have a whole network. So don't bother me with host 2.3, 2.4, just install the shortcut route for the whole network. And now the routing is being updated on spoke 1, and 192.168.2.0 now will go, because of the newly inserted routing entry, it will go between spoke 1 and spoke 2 dynamically. So we just created dynamic tunnel. It will be terminated if there won't be traffic flowing through it anymore.
One question, how is the tunnel encrypted, secured, whatever, but because they never exchange pre-shot keys certificates, how do they authenticate each other?
So So the question is, how do both spokes authenticate each other? They actually perform a regular IKE version 2 or full IKE version 2 exchange. So they need to have a means to authenticate each other. Pre-shared keys are probably in this scenario not the best idea because you don't know what will be the IP address of a remote spoke because it might use LTE, 4G, whatever. Probably certificates are the best way. So the easiest way to deploy it is certificate on every spoke with one CA. All the spokes trust this CA, and whenever they receive an IKE request with a certificate payload and certificate verify of a spoke that has a certificate from the CA, the same CA, we accept it. So the comment is that they are not reusing the keys that they had with a hub. This is true. There are other solutions which work in the way you described, that we are reusing the keys. Here in FlexVPN is very strong security. Even compromised hub does not see or cannot in any way determine what are the encryption keys which are being used between spoke 1 and spoke 2. So it's very strong security here.
NHRP works in the same way as in DMVPN for FlexVPN, or is it?
So the comment is there any or the question is there any difference between an HRP in DMVPN and Flex? Practically not, it's really the same. There is a difference in the logic. In DMVPN, we are not building any new tunnel interfaces. In FlexVPN, we are using here virtual access interface even between the spokes. So everywhere you will have point-to-point interface, even between the spokes. While in DMVPN, you would have one tunnel interface with multi-point GRE mode. Sorry? So the question is how is an HRP traffic redirect triggered? It's basically the same way as in the MVPN. If the hub is forwarding an HRP resolution request from the interface with the same network, NHRP network ID, to different tunnel interface with the same NHRP network ID, then it sends redirect. So the comment is, I mean, this is why we need this static tunnel between the both hubs. The tunnel 100, because we need an interface with the same NHRP network ID.
So how long does this shortcut be alive?
So the question is, how long will the shortcut be alive? Basically, as long 1/3 of the whole time.
So we refresh the entry at 1/3 of the whole time, and it will stay as long as the NHRP entry is there or the IPsec is there.
Yes, so Frederick has answered that we are refreshing the entry 1/3 of the whole time of an HRP hold time, and the entry will remain as long as an HRP entry is there, so the hold time or IPsec SA is there, whichever will be shorter.
And how long does it take to establish this shortcut?
So the question is, how long will it take to establish the shortcut? It depends on the latency in your network. Yes, it depends how many milliseconds it lasts. It takes for the IKE to establish between the spokes. Yeah, we need at least 4 packets between the spokes. So 4 packets, it depends on the round trip time. Sorry, there was a question there. So the question is, can we leverage an HRP authentication? Yes, yes.
If I have a flapping link between the 2 spokes and I want it to still go by the hub.
So the question is, what if we have a flapping link between the 2 spokes? Actually, very nice tag case that we see from time to time, and you still want the traffic to go through the hubs. I don't remember the command, but basically in the HRP you can say don't send resolution request for that specific address. So you can basically, do you remember, guys, the CLI for this? No, but if you don't want to send resolution request for specific subnet because you know there will be a flap for this. Purge? Yeah, there is a CLI for this. I'm sorry, I don't remember. There are 2 more questions.
What is it called? Indirection or redirection?
So the question is, how is it called, indirection or redirection? Yeah, it's called traffic indirection and or an HRP redirect. These are the two different names that we are using.
Do you ever notice about the bug if you have a flapping line between spoke 1 and spoke 2? Where the problem that the line goes down, after the line goes up again, where the problem that the shortcut was up-down. Our interface was up-down, so there was an unstable state and the connection could not be established between spoke 1 and 2. Do you know about that?
So the question is there any bug, or am I aware of any bug? What if there is instability between spoke 1 and spoke 2 and the tunnels might be up, down? No, we would need to look, maybe we can look offline into your, sorry. Frederick, you had the answer? Sorry.
Yes. So you can decide on the hub to apply NHRP or not, NHRP redirect or not for that specific interface, and that will prevent the whole resolution. So on a per branch basis.
Okay, so what I will just, sorry Fred, you didn't have a microphone, and maybe I should have passed you one. So basically on the hub, to answer the question on the flapping link between the spokes, on the hub we can say that for that virtual access interface, don't send traffic NHRP redirect. Yeah. So actually you can do no IP NHRP redirect only for that virtual access interface because of the way how we are creating the tunnel interface. So only one tunnel might have the NHRP redirect disabled, only with your one problematic spoke. Okay, let's move forward. For your reference, the configuration of the hub, what is really important here is this part here, so NHRP redirect, which you might disable for some of the spokes as we discussed, the NHRP network ID on our virtual template that is being used as a template for virtual access interface to the spokes, and the same NHRP network ID on the tunnel between the two hubs, to answer the question that we had on the condition of sending NHRP redirect. This is the IKE version 2 authorization policy. This is how we configure IKE version 2 routing. So this is how we configure what networks should be advertised by the hub inside of the IKE version 2 config exchange. So the comment is that you believe, that it works with only with GRE? Yes, it's a good comment. I should have mentioned it. NHRP works only with GRE. So please notice here we don't having tunnel mode specified, and default is GRE, and this is required for NHRP to work successfully. So we need to waste 4 bytes for GRE. Okay, spoke. I love the discussion, by the way. Please. Let's continue it. Spoke. This configuration of the spoke, our static configuration for the tunnel interface to the hub. Second tunnel as a configuration as a static tunnel to the second hub because for high availability, and the virtual template interface even on the spoke for the dynamic spoke-to-spoke tunnels, because we always want to have point-to-point interfaces. So we need a template to create a virtual access interface from. So this is the full configuration from the spoke. We use IKE version 2 routing. I already mentioned that it has some disadvantages, like for instance, lack of, it is not dynamic. So if the prefixes behind your spokes change, sometimes spoke should announce or should advertise specific prefix, and in different circumstances, maybe it should not. You might want to use some real routing protocol, like for instance, BGP. How does the BGP work in FlexVPN? We still need to use IKE version 2 routing to bootstrap or to prepare the basic IP connectivity between spoke 1 and hub 1. We basically want both sides to just have one route. So we want hub 1 to have a route pointing to 10.0.0.1, which is an IP address on the tunnel interface. And we want the spoke 1 to have a static to 10.0.0.254, which is the IP address of a loopback of hub. We want basically basic IP connectivity between spoke and hub. We don't want to announce the actual prefixes, so the LAN prefixes, but we want basic IP connectivity. It's because BGP is using TCP, so we need to have IP connectivity for that. But once this is being done, we are using regular BGP neighborship, and we are able to start exchanging the actual prefixes on top of it. Configuration. From the configuration perspective, I think it's quite straightforward. Maybe one thing to underline is that please notice here on the hub, we are using something which we are calling BGP peer group. It does not require you anymore, or BGP does not require you anymore to configure 1,000, 2,000, 3,000 neighbors. You can configure one big peer group, which will be like a catch-all rule, which will allow you to terminate 1,000, 2,000, 6,000, I think this maximum that we support neighbors. And with that, you have quite small BGP configuration, yes, because I know there is a myth that BGP configuration needs to, scroll screens. Not necessarily. You can use peer groups for that. If we compare IK version 2 routing and BGP, and this is example with IPv6 to make it more interesting, actually you can see that IK version 2 routing configuration is even smaller than BGP. So this may be an interesting thing, and this is how it looks. The same configurations, how they look in IK version 2 and IK version 2 routing and BGP.
BGP are running without encryption.
Sorry?
The BGP runs chains without encryption.
So the question is BGP running without encryption, is it protected? We are still running BGP over the IPsec, so it's still encrypted. Yes?
BRKSEC doesn't support ISIS. In the previous slide, you said that any routing protocol will support it.
So the comment or the question is DMVPN doesn't support ISIS. Is FlexVPN supporting it? This is the question. Frederick, can you help me here? Have you tested ISIS? Have you tested ISIS with FlexVPN?
We don't test ISIS or OSPF because they don't scale at all.
Fred, maybe wait. Let me give you the microphone. I think you need to turn it on.
Yeah, no. Where is it?
Oh.
All right. So we do not test ISIS nor OSPF because they don't scale well at all. They are very chatty protocols. Even EIGRP, which is a little less chatty, we don't recommend it because it doesn't scale. Again, we don't recommend doesn't mean it doesn't work. We just don't scale test it. So giving an example, OSPF will not scale beyond 400 branches. So you may think it's big scale. In the grand scheme of things, it's like reasonably sized network, but it will be more prone to flapping. Because in case of an LSA storm or something like that, the network will flap due to retransmissions. And ISIS will have the same issue. So yeah, we don't test it.
Yeah, we don't test, and actually, and we recommend BGP, to be very honest. In the high scale, either IK version 2 routing or BGP. This is what we would recommend.
So maybe for the sake of what we recommend is, we always recommend in big sessions like this, what we know is not going to create cases. Our job, Piotr, my job, is that we can go and have a beer and not cases.
Thank you. Any other questions, comments? Yes?
We are running MPLS over the tunnel. Is direct spoke-to-spoke communication supported or not?
So the question is about the dynamic mesh and spoke-to-spoke connectivity in MPLS, and here we are. Actually, thank you. Let's go now into the MPLS. Let's add the MPLS into the picture. So first of all, why would we use MPLS over FlexVPN? The use case is to do end-to-end VRF separation. If you are having one branch which is having a couple of VRFs, customer 1, customer 2, customer 3 VRFs, let's say, you're having another branch which is having the same VRFs, customer 1, customer 2, customer 3, and you want these VRFs to communicate with each other, but you want a separation, true separation. We saw designs in which, and sometimes it's necessarily when basically we can create multiple tunnels per pair of VRFs. So you can connect customer 1 VRF to customer 1 VRF on another box by having one tunnel. To connect customer 2 to customer 2, you can create second tunnel interface, and this is how you can go forward, although it doesn't scale. Yeah? If you're adding the VRF, one VRF, it requires massive changes on all of your spokes by adding static tunnel interfaces. So MPLS solves this problem, solves the scaling problem. So how does it work? I mean, or what are the specific or FlexVPN specifics when we are talking about MPLS? First of all, we don't need LDP, which actually increases the scale here, the potential scale here, because we are using point-to-point or back-to-back tunnel interfaces. We are using BGP VPN v4 or v6 to exchange the labels. So basically the first thing that happens on our devices is that all of the devices, they are having corresponding prefixes, like on this side, on this branch, we will have in the VRF red 192.168.1.0, and it will have a locally generated label or VRF label 31. We will have a summary route in the same VRF on our hub, and we recommend summarization or really extreme summarization here. So in the VRF red on the hub, we'll have 192.168.0.0/16, and the hub will generate a label 30 for it. And on this branch, we will have in the VRF red 192.168.2.0 with a label 32. So this will be locally generated labels initially when we set up the system. Now we establish BGP neighborship and VPN v4 because we are using IPv4. So VPN v4 neighborship, and with BGP, the devices start to exchange the labels. So now in the VRF red on our branch 1, we have also the summary route or the summary prefix coming from hub with a label 30 that was generated initially, if you remember, by hub. The same happens on our second branch. It has the summary route and corresponding label 30, which was generated by the hub. So at this place and this moment of time, the devices are ready to start sending or exchanging the traffic. This is for your reference how the full MPLS forwarding tables look like and how the routing tables look like. I will skip it, it's for your reference. I think the best to show how it works is the example. So let's say in the VRF red, we are sending traffic from 192.168.1.2 to 192.168.2.2. On this device, there will be a MPLS forwarding table lookup, which will determine the egress interface as tunnel 0. So it knows it should send the traffic to the hub, and it should use the label 30, because this is the label as it was announced by the hub during the BGP VPN v4 exchange in the neighborship. So as the end result, this spoke will send the packet with our source and destination IP addresses and a label 30. This label 30 on the hub, it tells the hub, hey, decapsulate this packet into VRF red. So basically the hub will take or pop the label 30, and based on this, it will know that it should decapsulate it into VRF red. So we are having our packet on the hub in the VRF red. So exactly the same VRF that was used at the source. Now, the hub still goes forward with the packet. It does another MPLS forwarding table lookup, and it determines the egress interface as the virtual access 2. So the tunnel interface towards our branch number 2. The label based on the MPLS forwarding table is 32, and it will send the packet to our branch number 2. Branch number 2 is doing, or spoke number 2 is doing pop on the label, so it is taking the label 32, and this is the label that it wanted to use for the VRF red. So it is decapsulating the packet into the VRF red. So we are having end-to-end VRF separation with MPLS labels being used as a multiplexing mechanism. There was a question about shortcut, and I promised to answer. NHRP, we introduced NHRP, which is MPLS aware. So in all the NHRP packets, like NHRP redirect or NHRP resolution request response, we added the labels. So everything is MPLS aware. As the end result, we are able to create dynamically spoke-to-spoke tunnels that are MPLS aware. So you will have, if there is a shortcut request coming in, for instance, between VRF red and VRF red, there will be a tunnel, IPsec tunnel being created, and if there will be a need to create the second shortcut in VRF green to VRF green, we will reuse the same tunnel, and we will just use the MPLS labels as the multiplexing mechanism. So one tunnel as a spoke-to-spoke is fully supported. So this is MPLS over Flex. For your reference, the configuration, I will not go through the details. I think the most important part is VPN v4. This is what we need to configure on the hub. Summary route that we need to advertise in every VRF that we want the hub to work in. On the spoke, VPN v4 configuration. And I forgot about one thing on the hub, MPLS NHRP. This is what you need to enable on every tunnel interface in your network that you want the MPLS over Flex to work in. So on the hub, we are enabling MPLS NHRP, and on the spokes as well, for the tunnel to the hub and for the spoke-to-spoke virtual templates as well. MPLS over Flex. Are there any questions? I was expecting a lot of discussions about MPLS over Flex. Are there any questions on this or comments? Yes? I see two. Yes? I will repeat.
Multi-hub solution, you need to perform the lookup in every time, in every hub.
In multi-hub, yes.
Sorry, the question is, in multi-hub deployment, do I need to do the...
You need to perform the lookup in every hub.
The lookup, the MPLS forwarding lookup, yes. There was one more question.
I just want to ask, can you disable the redirect, NHRP redirect?
So the question is, can we disable MPLS NHRP redirect? Yes. You can use MPLS over Flex in the spoke to hub only deployment without spoke to spoke if you want to. Yes?
Do you know with your platforms that it's available on, but for this specific features, is there any software version you need to consider?
So the question is, what for this specific feature for MPLS over FlexVPN, is there any specific platform or software required? I don't remember when we introduced exactly this feature, but I know that it requires, unless it was changed, because I remember there was a big discussion on this, the licensing, right? The APPX license is required for this. I know there was a discussion on if we should change it, but this is how it is today. Okay, HA, so high availability in FlexVPN. Our recommended designs in HA, they are based on the routing protocols. So very common scenario is you are having a couple of spokes. They connect to your hubs, at least two of your hubs, and you are having a couple of tunnels always up. From spoke 1, let's say, to both of your hubs, from spoke 2 to both of your hubs, etc. Now, the traffic can, in the ideal scenario when everything works, the traffic can go through both of your hubs, but if one of your hubs goes down, routing protocol, by means of a keep alives, it will detect sooner or later this fact, and the traffic now will be sent through the second working hub. This is really like no-brainer. This is very easy to configure with routing protocols. There is, though, and we are in TAC, there is a very common question that we are hearing is on how to increase the speed of convergency. So how fast can I go to detect the fact that hub 1 went down or the link to the hub 1 went down? There is, so yeah, the question is how fast can we do it? This is just an example on how the BGP, that you can actually do even the load balancing when you are having two hubs. Anyways, how fast can we go? With BGP, we can configure the timers to 1-3, which means that we are sending the hello every 1 second, and hold time is 3 seconds. So it means that you can detect the hub being down or the link being down as fast as 3 seconds. This is what BGP provides you out of the box. Yeah, and this is just how you configure it. You configure the timers in BGP to 1-3. Yeah, so 1 second ping or keep alive and 3 seconds hold time. If you want and you need to go faster, you can use what we are calling BFD, bidirectional flow detection. This is a mechanism of basically fast probing. It allows you to go to very strongly into the sub-second values. So you can configure, here in this example, I configured BFD to send a keep alive every 200 milliseconds, so 0.2 seconds with a multiplier 3, which means that the failure will be detected in 0.6 seconds, so sub-second. So if you need to go faster, this is what you can use. There is one caveat that I just wanted to underline. I mean, BFD is handled on our iOS XE platforms very efficiently. On ASR 1K, it's handled mostly in hardware, so you will not see spikes in your control plane because of the fact that you are sending keep alives every 0.2 seconds. Still, there is some overhead that you need to calculate when you are talking about so fast probing. If you are having 8,000 spokes and for all of them you are sending a keep alive every 100 milliseconds, you need to calculate how much bandwidth it will use, because now it's not something you can neglect. It can happen that it will occupy a serious amount of your bandwidth. You also need to take into the consideration what we are calling microbursts. At some point, it might happen that these keep alives will be sent at the same time. You will have thousands of keep alives being sent in 1 millisecond. And this is not something that your ISP might survive, for instance. So where I'm going with it is you need to be very careful with setting these timers very aggressively. Again, we are from TAC, because you don't want the timers, very aggressive timers, to cause more problems. You don't want the timers to cause false positives. You don't want BGP to start flapping because your ISP cannot handle very aggressive keep alives that you just configured. Yeah? So this is just something to take into the consideration when you are configuring these timers in a sub-second values. But it is possible, it is supported, and just a remark that please be careful with that. We have a proposal on how to do it in a friendly way, so your ISP won't be affected or won't cause the false positives. What we are proposing is, in the design that we already went through, is to set up the BFD here, between the hubs. Not between your hub and your spoke, but basically in your DC or in your main location to set up BFD here. So initially the traffic from spoke 1 goes to hub 1, or it can actually load balance. It depends how you pre-configured it. But if your hub number 1 goes down, by means of very aggressive BFD, and here you can go really, really aggressive because this is your LAN. Your ISP will not limit you. So you can do here very aggressive configuration. You can configure your system in the way that hub 2 will detect it in, let's say, 0.5 seconds or even more aggressively, and it will send the information to the spoke. Hey, hub 1 went down. Don't send the information to it. You don't know it yet. Dear spoke, you don't know that your hub is down yet because your BGP is configured to detect it in 3 minutes. But hub 2 is informing the spoke 1 that, hey, there is something changed. Hub 1 is not available anymore. I will not go into the details of this design now and today. There is an article that I've published externally on that. There should be a link popping up, or there is a link. So I've published this article externally where I'm showing exactly how to configure the design if you are interested in. But in general, the goal is not to use the BFD over the WAN, just use it on the LAN. There are a couple of event managers here. Yeah, I decided not to cover it today, but to describe it here. Any questions, comments on what we covered now?
Scaling BGP. So if we have, let's say, 10,000 tunnels, like we do, what goes to an essentially?
So the question is about scaling the BGP and if we are having 10,000 IX sessions. I think we were testing BGP into 6,000. Yeah, so 6,000 is something that we tested and it worked fine. Above that, yeah, we had problems. What was the box that we tested in on? ASR 1002X, I think.
Even 1002, yeah, yes.
Yeah.
One X should work. Everything should work. One X should be fine.
Yep.
One X should be fine.
We can have a discussion about this afterwards. So yeah, 6,000 is what we saw stable with BGP. So we discussed routing or routing protocol-based HA. Now FlexVPN has some embedded HA which you might want to use, especially in the scenarios in which, I mean, having 2 tunnels always up from your spoke to both of your hubs is basically a waste of resources, especially if you are having active standby kind of deployment, because you are having 2 times more tunnels that you need, right? So maybe instead of having 2 tunnels always up, you would like to have a design in which if your hub number 1 goes down, the tunnel is being redirected to hub number 2. You don't want to have 2 tunnels always up, but you want to change the destination of your tunnel dynamically. You can achieve it with FlexVPN on the client side. So we introduced client part of FlexVPN. We call it FlexVPN client or FlexVPN client block. This is the part of the configuration, FlexVPN client block, and it allows you to configure multiple peers, multiple destinations. So you configure here what are your hubs in a list, in an enumerated list, and under tunnel interface itself, you are saying destination is dynamic. So you don't configure destination, you are saying destination will be determined by FlexVPN client block. And in this way, you can achieve what I just showed a moment ago. You can have your client connecting in the given order to your hubs, but you have only one tunnel up, yeah? So you don't waste resources if you have, for instance, smaller routers which are having limited number of IPsec assays that they can handle. At the same time, this CLI is really super powerful. You can see the big slide. Some of the features that are worth underlining is FQDN and dynamic FQDN resolution. So you might use FlexVPN client block with a DNS entry, and you can resolve the DNS entry upon the connection. So you can do DNS load balancing. Yeah? If you are having one template of your configuration, it might have one DNS entry, and that this DNS will return the IP address that is relevant, for instance, to this location, to this continent, to this country, to whatever your DNS provider can support. Yeah? So FQDN, you put here FQDN and you put the word dynamic, which means resolve the DNS upon connection. Very nice feature. We are having also FlexVPN backup groups. If you want to have always two tunnels up, let's say you have 3 hubs, but you would like only 2 tunnels to be up always because you want to do load balancing, you can do it by configuring 2 FlexVPN client blocks and to pair them with what we are calling backup group. You are like merging them and you ask the system to treat this both FlexVPN client blocks to act as one. The end result is that first FlexVPN client block will determine the destination of a tunnel as a hub 1, but second FlexVPN client block will say, okay, in this backup group block, we already have connection to hub 1, so let me not connect to it, let me connect to hub number 2. So by using FlexVPN backup groups, you can configure n out of n connections being up always by adding the groups. So dynamic tunnel destination, we can also do dynamic tunnel source. What is the use case for it? Let's say you are having 2 service providers, 1 hub. You want to use first service provider as your main one. It's, let's say, your cheap landline internet provider, and you want to use it by default. But if it goes down, you would like to fail over and change the tunnel source to, for instance, 3G or LTE link, yeah? But you don't want to touch it until you don't want to touch your LTE link unless you really needed it, because it's, let's say, expensive. So how you do it? You configure a track here to monitor your service provider in some way. You need to determine, the router needs to determine if your ISP1 is down or up. If it is up, the tunnel source is being used gigabit Ethernet 0/0, but if it goes down, the track goes down and the tunnel source is being changed to fast Ethernet 2/0. Tunnel source being dynamic. And actually you can, as you can see in this example, you can combine both. You can have tunnel source and tunnel destination being dynamic. And then, you know, you are still having one tunnel, but the possibilities of how many tunnel sources and how many tunnel destinations you are having are quite big, yeah? But still one tunnel.
How fast it will fail over, switch over between?
So the question is how fast it will fail over between sources. It depends on what track you are using, and basically the speed will be determined by the track, because if track will be assigned to SLA, which is ICMP ping, it depends on how fast the SLA will go down. And the tunnel destination, just to answer this, the tunnel destination will be changed based either on track, because you can associate, let me go 2 slides back. You can associate peer to track, even for destination. So you can say, let's use this hub as a destination, but if this track goes down, I would like to fail over to the second one. So in this scenario, you can use track, and then you rely on the timer of a track, or you rely on the IKE timers, on the DPDs of a. In this scenario, for instance, when you are not having any tracks configured, we basically rely on the DPD timers. We connect to the first hub. If it goes down, DPDs, IKE DPDs will detect it, and DPDs you configure here. 30 seconds interval and 2 retries. So around after 45 seconds, we will detect it and we will go into the second peer. There was a second, there is a question here.
We can use 2 tunnels at the same time. So the IBAN and the VPN we use PFR, and we can send the traffic, the voice to the one tunnel and the data to second tunnel, yeah? The FlexVPN can.
So the comment or the question is, with DMVPN we can use PFR to do performance-based routing and send some type of traffic to one link and some type of traffic to another. The answer is in FlexVPN we don't support PFR. You can still do it though with other mechanisms like PBR or a regular routing, okay? But we don't support PFR. There was one more question.
So if you go back to the last slide you showed here on the track, have an HRP and you change the source of a tunnel. The hub says that private IP address, the tunnel IP address is already associated with a different IP, so there's a unique conflict. So it depends on the association of the hub. It has to be deleted and a new one created, so that increases your time of conversion.
So the comment is, if our hub would be a FlexVPN hub but with NHRP enabled because we want to do the dynamic mesh, then if we change the tunnel source, the NHRP registration normally with the default settings will fail because there is already a host registered with the same tunnel IP address. We can disable that feature by disabling unique in NHRP registration. So on the spoke you can say no unique, and then it will basically mean you will override on the hub will override the previous entry. So it will not increase the time on your spoke. So the question is, where do we configure it? On the spoke. Okay. Load balancer. We are approaching the demos, just the information, but yeah, load balancer, the last topic of a site to, almost the last topic on the site to site. Load balancer allows you to configure a couple of routers to act as one, as a tandem. Or you can have a couple of hubs working basically as one. How does it work? We are configuring HSRP. So what it means that your hubs, they need to, on this site, if you are using your hubs in the internet, you will have a public IP addresses here. So this is maybe something not typical, but this is what we are proposing, to have a public IP addresses on your hubs. One of them will claim a role of an active, so one more IP address. So here we are having 3 hubs, you need 4 IP addresses. So one of them will be elected in HSRP as an active, and we are also using Cisco load balancing, CLB, and one of these devices will claim a role which we are calling master. Now all the slaves are reporting the status to the master, the status of how much memory is consumed, how much CPU is consumed, how many connections, IC connections I already have. So basically the master knows what is going on in the whole FlexVPN cluster, how busy is every router in that cluster. So now when the client connects, and by the way, this technology is standard, it's not Cisco specific technology. We are using here IC version 2 redirect message, and it is supported by Cisco routers, by AnyConnect, but also StrongSwan, and probably some of our competition will support it. So as a client, you might have whatever supports IC version 2 redirect standard. Maybe interesting fact. So when we are having a client connecting, the client will connect to virtual IP address, so to the master, the IP address that is currently claimed by master. Master will determine what is the least loaded gateway, which box, which router is doing the least at the moment, and it will send the message which we are calling redirect to the client. So the client will be informed, okay, please reconnect to hub number 3, because this is currently the least loaded gateway. And the client will basically establish new connection to the hub number 3. From hub 3 perspective, this is just a new connection. It doesn't even know that this connection is coming from the redirect. And this is how FlexVPN load balancer works. Advantages of it, you don't need to use the same hardware and the same software. So you might start in your cluster with 2 ISRs 4000, and if your network grows, you can start adding different devices in different software, ASR 1K, CSR, whatever. So really, pay as you grow kind of model with that functionality. From the configuration perspective, We configure HSRP, but the named HSRP, so we need to use name keyword, and we create Ike version 2 cluster, and we associate cluster to the name of an HSRP. On the client side, we are using FlexVPN client block, even though we are having just one peer, which is the virtual IP address of our cluster. This is how it was implemented. FlexVPN client block is being required, even though it will have one destination on one peer. So FlexVPN load balancer. How do you authenticate peers, meaning hubs? So the question is, how do we authenticate hubs in the cluster? The answer is we don't. Yeah. We are using HSRP. There is some HSRP password, I think, but I don't think it's super serious. Yeah, it's MD5 or something, right? So, yeah. So I would say we don't. Yep. Sorry.
About the client block, does it support
Ah, yeah, yeah. Okay.
does support more than one peer? Let's say that we have a DR scenario where we have another FlexVPN load balancer on the DR side, and if the running goes down, does it to redirect the traffic to the cluster? Is it possible? Is it viable?
So the question is FlexVPN client block supporting multiple peers as a
Cluster.
So this thing here, can it redirect it to the another, like a DR? It requires HSRP, so you would need to somehow establish HSRP with your DR, which might not be super possible.
It doesn't support like separate HSRP groups where we can say on the client or the spoke that if this load balancer.
No, this you could do, because on the client, so sorry, the comment or the question is, can we have multiple clusters that we are connecting to? Yes, we could have peer 1, which is cluster 1, Europe, main data center, and then peer 2, Europe DR, for instance, right? And yes, and then if the first cluster doesn't respond, the client will connect to the second, yes. So now, really, to finish the site-to-site, and we are talking about massive scales because of the load balancer. We can have up to 10 devices in the load balancer, 10,000 IPsec sessions per hub. This is maximum what we support today. So with load balancer, you could go to 100,000 sessions, yeah, with the 10 devices today. This is the scale that you are able to do with it. When we are talking about deploying or configuring spokes, right? Theoretically, you can pre-configure the spokes in your main location, and you can start sending them out into your branches, into your final locations, although this might be problematic. We have some proposal to address this problem. So maybe to do a step back, in the CA servers today, if you are having your CA server, you can grant certificates automatically. So basically your CA server accepts the certificate request from anybody who makes a request. You can configure it manually, so you need to manually approve every certificate request, or you can configure something which we are calling grant auto trust point. And this means that CA server, this is iOS CA server, will grant only certificate when the certificate request is signed by this trust point. Now, what is the use case for it? On our routers, we are having what we are calling SUDI certificate, Secure Unique Device Identifier. This is what SUDI stands for. We are having SUDI certificate is basically this. Maybe let's talk more technical. This is an example of a certificate from 891 router. This is what we embed or we pre-install during the manufacturing process of a router. So when you buy Cisco router, modern Cisco router, it will have this certificate pre-installed, and it will be signed by our Cisco manufacturing. This certificate will contain serial number here, and this is something we might want to use. So what we are proposing is to ship your routers directly into your main location. Don't send it into your IT department location, just send it directly into the destination, to the final destination location. Our routers are having a property that if they don't have startup configuration, they are quite fancy about where they are looking for the startup configuration. One of the places that they will look at is USB stick. So if you plug in USB stick into the empty router that was just manufactured, it will load the configuration from a file which we are calling cisco.rtr.cfg. So what we are now proposing is to install some very minimalistic and small configuration in this file. So we are having non-technical or non-super technical personnel in your remote branch. And that person just needs to connect the router, plug in the power, insert the USB stick with the Cisco RTR CFG configuration that you created and you sent it somehow using the, I don't know, mail or email, whatever. And this configuration will trigger the spoke to do a SCEP request. It will ask your hub or a CA server for a certificate. But this certificate request will be signed with a SUDI certificate. So now your CA server knows what is the SUDI certificate. It knows also the serial number of a device that asked for this certificate. So you can have a Radius database with a list of your serial numbers, and if the serial number is on your list, if this serial number is something that you really bought and it should be in this remote location and this place at this time, your Radius might accept such a request, approve the request, confirm that the serial number is really something that you are having in your network, and as a result, the CA server will respond to or will approve such SCEP request, and you are having on your spoke certificate which allows you to, for instance, establish through VPN tunnel, and then over this VPN tunnel you can finish your configuration, you can send the rest of your parameters. So basically with this method you are able to authenticate and onboard the devices by trusting the SUDI certificate and by validating their serial number. And SUDI certificates, by the way, are installed in the tamper-resistant chip. There is special ACT2 chip in most of our hardware. So this certificate and the private key corresponding to this certificate should be tamper-resistant, yeah, by the nature of hardware that we are using. Yes?
How do you configure the hub in regards to the certificates? I mean, do you need to install your CA certificate on the hub?
So the question is, how do we configure the hub, and do I need to install CA certificate on the spoke?
No, on the hub. I mean, if spoke has your certificate, I would assume that the hub with your, Cisco CA certificate.
So the comment is, how do we configure the hub, and do we need to import the Cisco CA, manufacturing CA? Yes, we need to. And the example of this specific configuration, there are 4 hidden slides after this one in the PDF that you should have an access to, where I dump the whole configuration on how to configure it to authenticate with Radius.
Where do you get the certificate from? Cisco CA?
So where do you get the Cisco CA certificate? First of all, it's on any device which is having SUDI certificate. And secondly, it should be publicly available, and it is also in the next slides. Yeah. So zero touch deployment. Zero, I'm saying in quotation mark because still somebody needs to connect the power and plug in the USB in the proposed design. So we finished first big section, site-to-site VPNs. Any questions on this? Still, maybe? On FlexVPN client block, on MPLS. Okay, let's go into remote access then. Heart of remote access with FlexVPN is AAA integration. So you remember we were at the very beginning talking about the virtual templates and the virtual access interfaces that are being created outside of the templates, and we are associating parameters per user, per type of users. In FlexVPN, when we are talking about AAA integration, what I mean about AAA integration? I mean, what does it mean? Authentication basically is to confirm that the credentials that were entered by an end user in the remote access are correct. If the user has proper certificate, this is the authentication phase. And now authorization means what access the user should have. But in FlexVPN world, it means what should I apply on the virtual access for this user? So in the authorization phase, we will determine what QoS policy should be applied to user Piotr, what QoS policy should be applied for user Frederick, for instance, right? So this is what we will do in the authorization part. So how does it look at the high level? First, we are doing authentication, and in the remote access, mostly the authentication will be done by your AAA server. You are having your users stored in LDAP, in Radius, Rather, we will not store the users on the routers itself, because you already have a database. You probably already have an Active Directory with a database of your users. Now, authorization, we can also use AAA server. We can use we can configure authorization locally. We will go through some of the use cases in a moment. But in authorization, this is what we are doing. We are saying what configuration should be applied on our virtual access interface, what DNS, for instance, should be passed over to our remote access client. We need to configure DNS, for instance, for our remote access client, and what pool should be used to assign, for instance, the IP address. This is what will be done in the authorization. And there is an accounting, so we want to account when the user connected, when the user disconnected, how many bytes were transmitted, what IP address was assigned to that specific user. Very useful if you are having, for instance, SOC and incident response. Probably accounting is something you want to have always on in such scenarios. So when we are talking about authentication, we can use certificates for authentication. It is an option. You deploy the certificate to your client, and you are just doing bidirectional check or trust check. And if the user is having proper certificate and proper private key corresponding to the certificate, you are allowing the access. The authentication goes through. If you are having, or if you want to use standard-based authentication, so let's say your remote access clients are non-AnyConnect, so not Cisco AnyConnect, but native Windows client, native Mac client, native Android or Apple phone, you don't want to use AnyConnect, you need to use also standard authentication protocols. And standard authentication protocol is IP. How IP works, we are having IK version 2 between the client and the server. We are having radius between the server, FlexVPN server, and the radius server, and there is IP inside of it. And IP might allow you to do username and password authentication, and this username and password credentials will be passed directly to the radius server. So actually it's a radius server that is performing the authentication. FlexVPN server is just the box which decapsulates IP payload from IK and re-encapsulates it into the radius. And if the credentials are good, AAA server is just informing FlexVPN server, hey, the credentials were good, you can proceed. Yeah? But the FlexVPN server in this scenario is not aware of what is going on in IP. So in this scenario, if you are using IP protocol and you are saying authentication failed, if this is the message that you are seeing on your client, you probably should look at your radius server, not necessarily at the FlexVPN server. When you are using IP authentication, we need to use certificate to authenticate the FlexVPN server. So first we need to make sure, the client needs to make sure that it is talking to the valid FlexVPN server. You don't want to send credentials to some compromised FlexVPN server or to not trusted FlexVPN server. If you are using AnyConnect, we are providing a method which is Cisco specific. We call it AnyConnect IP or aggregate auth. And it allows you to terminate authentication on the FlexVPN server itself. So you don't need radius anymore. You can use a local database that is stored on your FlexVPN server itself. If you want, you can use LDAP, for instance, to consult your AAA server. It's really up to you. This protocol is using XML, so no third party will support it. This is something we created. It is supported only by AnyConnect client and only Cisco hubs. Yeah. So this is how it works today. So yeah, you can configure a local database for the users, or you can use LDAP if you have an Active Directory. This is the configuration for your reference, how to connect directly your FlexVPN server to LDAP without any intermittent. So if you don't want radius server, if you don't want to set up Microsoft NPS, you go with this configuration with LDAP and aggregate out, meaning AnyConnect as a client. Configuration for your reference on how to integrate FlexVPN server with Active Directory. Aggregate out allows us also to do dual authentication, so you can do certificates plus username and password. So these let's say two-factor authentication. Yeah, this is how you configure it. There's just one small change in the IK version 2 profile. You add cert request, and then it means the certificate is also obligatory. So, but this works only with AnyConnect as a client, only aggregate auth. Yeah, I think it's time for the first demo. Okay, so this is, by the way, the thing on the right is my phone, my real phone, yeah? So it's not some simulation. So I have an Econnect client which is connecting to my FlexVPN server, which is CSR. I'm logging in with my credentials. I'm using here aggregate out and the local database, so my username and password are stored on CSR itself. I connect, and now I have a request to approve this connection on the phone. So multi-factor authentication, and we are using here our latest acquisition, Duo Security. You can approve the connection on the phone, so multi-factor authentication, and you can go forward. It works very nice with FlexVPN. So how does it work? Yeah? The multi-factor authentication and the approval on the phone, the addition. Basically, Duo Security allows you, I mean, there are probably 10 ways to do it, but the easiest one is to use Radius server that is provided by Duo and probably any other multi-factor authentication provider like Ping ID and others. FlexVPN server sends an access request with its credentials. We are using here aggregate out. So the username and password will be sent to the AAA server. You saw the pop-up. AAA server, so Duo is sending information to the cloud. Hey, do this pop-up on the phone of the user. Then on the phone on the user, I clicked approve, and then the Radius server is sending access accept. So this thing here takes some time. What is not nice is that on the client, the only thing that you see is please enter your username and password. Yeah? You don't see, hey, please find your phone and please approve. You don't see this message. We cannot add such customization at the moment, but we are discussing it with the Econnect guys because it would be better, yeah? If you would see here a message, please, find your phone and approve. Yeah? Just this message might not indicate that we are waiting actually for approval on the phone. So this may be a small caveat for today, but it fully works and it's fully supported. So authentication with MFA with Duo Security. Authorization. So how do we associate our parameters to the session? We are having, during the authentication, when we are checking username and password, in the Radius protocol, Radius will tell this user and password are okay, access accept. But in Radius, in the same packet, the Radius server might optionally send already some parameters, like this is the IP address that should be associated to this user. This is the DNS that should be used by this user. It can happen already during the authentication phase, so already in the first step. If you want, you can basically accept these parameters. It's up to you if you want to accept them or not. Yeah? In the authentication phase, what do you want to do with these additional parameters? If you want to use them, you can configure what we are calling implicit authorization or cached authorization, and then it means that the parameters from the initial access accept will be taken into consideration. If you don't want to accept these parameters, you want to reject them, and you want to consult different Radius server, for instance, for authorization. So you're authenticating with one server, like Duo Security server, but authorization is being done in different, or is being configured on different Radius server, or locally, you can do it. We are doing then what we are calling explicit user authorization. And so these are the two differences. Implicit means we are taking parameters from authentication, and explicit means we are ignoring parameters from authentication, and we want to do explicit authorization to the same Radius server, to the same Radius server, or to the different one. If your users are part of some group, like for instance, Piotr is part of TAC or engineering, you don't want on your Radius server to configure common parameters for the group, like a DNS, which is common for the whole Cisco. I don't want on my Radius to configure for every single user DNS server, yeah? Because then if I need to change DNS server, I will need to change it in 70,000 places. Instead, you might want to create an artificial user which is representing a group of users or a type of users, like for instance engineering. And then FlexVPN server can perform additional authorization. It can ask what are the parameters for the group of the users, like engineering. And for instance, DNS server is additional parameter for the whole group. We call it group authorization. So you're having user level authorization and group authorization. And FlexVPN server will merge these two parameters. For your reference, this is how you configure all of this. Merging algorithm described for your reference, I will not go through it, but the question is which parameters should take a precedence, user-based authorization or group level authorization. You can actually configure both, and you can see, this slide describes how the exact algorithm is working. How the authorization looks from a Radius server or from a AAA server perspective. This is what you configure. For instance, this is a paste of the configuration of FreeRadius. This is how it looks on FreeRadius. Group engineering, we want to use this DNS server pool. We want to assign this VRF and this IP unnumbered loopback1 parameter to our virtual access interface. If you want to do it locally, because you don't have a Radius server, you are using this parameters IKE version 2 authorization policy and AAA attribute list to configure what should be applied on our virtual access interface. This is local configuration, and this is the same configuration but on FreeRadius. So these are the examples for authorization. So maybe to put it all together, because this is one of the most complex part of today's session. Let's go step by step what happens when our remote access client connects to FlexVPN to structure it a little bit. So the first thing that happens is our client connects, it introduces itself. It is saying, hello, I'm a client, this is my identity certificate, and I would like an IPv4 IP address. We are using here config exchange, the same config exchange that we talked earlier about when we were talking about hub and spoke deployments. What will happen is the FlexVPN server will match the identity based on the key ID. So identity that we are matching against is key ID IT. This was the identity here that our client sent. So client said, hello, I'm IT. My identity is IT user. We are matching the identity of type key ID here, and we are landing in the profile IKE version 2 profile default. Now we are performing authentication. So we are verifying if the user has a valid certificate and valid private key corresponding to that certificate. Once this is being done, we are using what we are calling local. I mean, basically here we are doing local authorization. So we are having flex local authorization list, which is defined here at the top, which is saying we will use local. We will not use Radius, we will use local configuration. So the configuration stored on the router itself. And here is our configuration that resides on the router. We will take the user's IKE ID, so the identity, and we will try to find IKE version 2 authorization policy with the same name. So this parameter sent here by the client is the part of the configuration that we are looking at. Yeah? So it's a client which is determining what policy it will receive. So the client is saying, I am IT user, we are choosing authorization policy IT, which is saying pool IT pool should be used. So this is the pool from which we will give the IP address to the user. And we will apply IT-list parameters on the virtual access interface. So these are the parameters. So this is how we do authorization, based on the user with identity IT. So we allocate IP address from a pool IT. We clone the virtual template. So this interface here that we defined as a template, we take this is our template, we clone it, we create a virtual access interface. We take these parameters, tunnel mode, IPsec, IPv4, tunnel protection, IPsec profile default, we put it here. But we also add the parameters that came from authorization. So these parameters here, we merge them, and we have our virtual access. So our virtual access is virtual template plus what we got from AAA, which is what we configured here. and we have virtual access. Now you can configure thousands of policies like this, IT or per user, it's, per group of the users, per name of the users. You can export all of that to your Radius server. You can have 100,000 different policies, and you can have basically policy per user. And then every virtual access interface will look differently. So super big customization. Yeah, this is really unique feature of FlexVPN, integration with AAA, creating these virtual access interfaces, and everyone can be different. Once we are done, we are just sending in IKE version 2 configuration, exchange the IP address to the client, so the client can start browsing the resources. Yeah, but that's it. So the question is, to find the authorization policy or to match the authorization policy, can we extract the field from the certificate? Not today. Yeah, we are working on it, but not today. Frederick, you looked at me, did I say something? We don't support it, yeah, we don't announce it. Okay. No, I'm sometimes looking at Fred because Fred is working really on the roadmap and some things, that are ahead, and I might not be aware of it, but yeah. Never mind. Yep. So no, today you can do only the lookup based on the identity. So based on the IKE identity, we are working though on the we actually have a working prototype where we extract fields from the certificates, but yeah, it doesn't work yet. Sorry.
Usually we configure any connect the gateway on ISA, so it should be stopped.
So the question is, usually you are using any connect with ASA, should you migrate to FlexVPN? Is it your question? I mean, not necessarily. The ASA is fully supported and remote access works there very well, but if you are having new deployment and ASA doesn't satisfy it for whatever reasons, this is an alternative, I will say. Yeah? It's not a migration path. Yeah? No, there is no need to migrate from ASA to FlexVPN. If you know ASA, this is tunnel group. IKE v2 authorization policy is a tunnel group on ASA. That's it. Yeah. Yeah. A couple of questions. I will start here.
How many clients can connect in?
You are asking about license?
How many any-connect clients can connect in?
So from the license perspective, we are licensing AnyConnect as a client. So you are paying basically per client. Yeah? I'm not from a licensing, I'm not from sales, but from what I know, we are licensing clients. On the hub itself, maximum that the box can handle with a security K9 license. So 10,000 on the ASRs. There was, one question, 2 questions here.
Does this integrate with ICE, the FlexVPN work with ICE?
I'm sorry, could you repeat?
Does this work with ISE?
So the question is, does it work with ISE? Yes, yes. And actually, the demo that I was doing, and I have one more demo. Let's see if we'll have time to do it. Is with ISE. So yeah, it works very well with ISE.
You have load balancing. You presented load balancing for the site-to-site tools.
Yep.
You have the same for remote access.
So the question is load balancing working? I showed it in the use case of site-to-site. Will it work also with remote access? Yes, you can. Sorry.
Do they have to be next to each other? You have to use HSRP or may you use something else?
So the question is, do they need to be next to each other? Yeah, they need to use HSRP to use FlexVPN load balancer, but you can use different mechanisms of load balancing, like DNS, for instance.
For sector, you can build 2 for your remote access, 2 tunnels.
Can you build 2 tunnels up at the same time with remote?
For site you can do. Can you do the same for this?
So we cannot do with AnyConnect more than one active VPN tunnel, but there might be a different client that allows this to be possible. Yeah? But with StrongSwan, yeah, you can do it because this is what we do in TAC for what we call attack reproductions. Yeah? If we have a massive case with 5,000 clients and one of them sometimes flaps, we use StrongSwan to simulate 5,000 or 10,000 clients. So this will work. So yeah, this is remote access, but also FlexVPN as its power. Yeah, this is really something unique, and you can see actually I'm super excited about this. Yeah, because this is a use case that you cannot really achieve with anything else. We talked a little bit about the clients. The choice is not super obvious on what to use in remote access as a client. In TAC, we recommend and we prefer when you use AnyConnect, because then we can troubleshoot and support both client and the server. It's both Cisco. We have an engineering group behind AnyConnect. We can contact them and we can discuss if there are any problems. Although from a functional perspective, both are, I mean, all the clients are equal. As long as they are supporting IKE version 2 as a standard, all the clients will work. Yeah? So native clients, Strong Swan, whatever other client that you can imagine will work. Yeah? But from TAC perspective, we like, and probably it's also better for you if you are having one vendor which is supporting end-to-end your solution, but this is not a requirement. It's a recommendation. When you are using AnyConnect, and there was a comment that AnyConnect mostly is being used with ASA. It is true that AnyConnect was designed to work with SSL. And here we are not in SSL world, we are in IKE version 2 and IPsec world. So you need to instruct your AnyConnect not to use SSL and to use IPsec instead. How do you do it in AnyConnect? You are having a file which we are calling profile, VPN profile. This is basically an XML file like this one. You edit it, you don't need to edit it in like an XML directly. You have a profile editor. This is the tool here. Where you can edit this, you can create this XML profile, and you can instruct the client, you can create the profile which will instruct the client to use IPsec. Yeah? The question is, how do you now deploy this profile to the clients? Yeah? There are a couple of options. One that we just introduced, and this is the feature that I was working on from a TAC perspective. One is you can download the profile from a headend. This works only on CSR 1K today. So basically you take your AnyConnect, you put an IP address or a hostname of your CSR, or CSR because this is the only supported platform for this specific feature, and the connection is being done using SSL, and the profile is being downloaded using SSL. And then your user can disconnect and reconnect using IPsec. So the initial profile download is being done using SSL, but this is done, and this is by the way how ASA does it as well. So we basically copied the behavior of ASA. But this works today only on CSR 1K. Let's see how it will look in future. Once you are connected, so once the profile is already there on the client, when you are connecting using IPsec and IKE, we are all the time sending the hash of the profile. So if you change your profile on the headend, automatically it will be updated on the client as well. And this update process is done also using SSL. But this part, so update of a process, of a profile is supported on all platforms, not only on CSR 1K. So it will work on everything. This is a relatively new feature because it's 16.10, so we are talking really last months. So the update of a profile was not possible earlier. What are other ways to deploy the profiles? You can of course just copy the XML file into proper directory. You can send it with email if you have any outbound MDM tool, like device management tool for your employees' laptops. You can use it for mobile devices. You can install it. You can send this nice link over the email, so the user can click, and the AnyConnect will configure the profile for the user. You can configure it manually on the mobile device. But on the mobile devices, I do recommend to use this, which is MDM. Yeah, this is actually Meraki, so Cisco Meraki MDM, but any MDM will do. You can configure using MDM IPsec profile, and this is how the configuration of IPsec profile looks in Meraki MDM, but I guess you can just copy paste this configuration to any MDM. So this configuration allows you to pre-configure your employees' mobile devices, so they don't need to even install AnyConnect and configure AnyConnect. It will be just done for them if you are using MDMs. Yeah. We are big fans of it. Cool. So this is when we are talking about deploying of the profiles for AnyConnect. I think it's a good time for the last demo. There was a question about ISC. and I wanted to show it, to show the demo which is relevant to it. Does it work? Yeah, it works. So I have here an Intel NAC with eyes here on at the desk and a couple of CSRs and Windows machine. Yeah, so what I wanted to show you is in my Windows, I have Windows Update disabled. So the service to update my Microsoft Windows box. Yeah? This for you as an administrator and for your security department might not be something that you like to accept. Yeah? You rather would like your users to have Windows Update enabled to avoid known vulnerabilities. So what we can do now, we can push the policies the policies meaning I would like to quarantine, isolate users who are not having Windows Update enabled. I would like to put them I would like to associate access list to them which doesn't allow to do anything else than, for instance, accessing update server. This might be my policy. So what we can do with FlexVPN, sorry, I forgot my password. It's a new month, so I need to add the 1. It's February or January, yes? So 1 or 2. Okay, I connected. Last year in Vegas, I had caps lock and this didn't work. This year it worked. So I have Windows Update disabled, and AnyConnect will download policies from ISE. It will perform a posture check, and it will realize that, hey, update is not enabled. Now the user, let's say, I would like to do ping.8.8.8, so I would like to access Google DNS. It doesn't work. Now let me go to CSR to show you how it looks from a server perspective. I have an interface which is, let me increase the font, which is virtual access 1. And now, let me scroll it up. Now we have an access list which is called block associated to this virtual access. And this access list is saying deny IP any. Now if I turn on the Windows Update, and I do recheck, so I will perform it, I will ask the AnyConnect to check again. I could do it manually, and by the way, on ICE I could say even, I could push the change to Windows Update service. I could enable it, but then the demo wouldn't be that nice. So I did it manually. And now what happens is my ping started to work. But please notice that my VPN session was not disconnected. I was continuously connected. The only thing that changed, that changed was the policy. And the policy, if I do again on my CSR, the policy changed. So the access list changed. From block, it changed to allow. We are using here change of authorization, so a special packet, radius packet that is sent by ISE to our FlexVPN server to instruct the server, the FlexVPN server to change the parameters for that specific session dynamically. So you can change the QoS. You might want to initially limit the user to 1 megabit to 100 kilobits. You can then change the parameters of this user to something completely different. It works with posture, but you can imagine also scenarios that you can use the same technology with non-posture use cases, even non-remote access use cases. You are having side-to-side VPNs. You are having your users or your customers who are having 1 megabit VPN created, and you initially limit their connection to 1 megabit, but let's say they pay a little bit more, you send COA and you change the policy to 10 megabits without disconnecting the IPsec session. So this is what change of authorization packets allows you to do, and there are 10 hidden slides on this, how to exactly configure it with the print screens of ISE. So I will not bother you now with it, but if you are interested, you have all the references in the PDF. There was a question. I'm sorry? Can we use for scout? I mean, it depends. As long as the posture client, we support COA, and COA is a standard. Yeah, so this is regular standard. As long as the Radius server supports COA according to the standard, it will work. The only maybe thing to underline is if you will talk to the third-party vendor, if they support proper COA, we support COA of a type push, and this is not something super commonly supported. Yeah, so this is maybe something to be discussed with the third party. Was there one more question? Okay, the last topic, really the last. And this is the time when I give away the book. Let's say we are having the network and topology that we discussed already multiple times. Let's say that this spoke is being compromised. What the spoke attacker on that spoke can do? And actually something changed in this slide. And Frederick, you have a book already, right? Yes? Anyone notices the change? Default route? Sorry, here was the first proper answer. Default route by itself would not change too much. We want to insert more specific route, and this is what gentleman here said. Yes? Yes, sorry, the gentleman, you are right. Yes, the gentleman here responded first. So yes, what attacker can do can insert more specific route instead of 192.168.1.0, attacker can inject 0.0/17, which is still more specific than /16 that the hub had in its routing table before. What is the end result? The traffic is suddenly routed to this spoke 1, even though this the traffic that should not be routed to spoke 1 is routed to spoke 1. Even the traffic originally destined to spoke 2 still lands with spoke 1 because of this change. At the same time, attacker can inject the traffic, can start injecting the traffic, and by doing it cleverly, attacker theoretically can do even man-in-the-middle attack for the hosts which are in the spoke 2. Super difficult attack to be detected unless you are having proper auditing. How do we recommend to address it in FlexVPN? Config exchange, we discussed. Hub sends the networks to the spoke, and now our attacker changes the configuration on the spoke and is advertising 192.168.0.0/17. What we might want to do in our Radius server, in our AAA configuration, we can say route accept deny, which means don't accept the routes, don't trust what the spoke is telling to you, ignore it. Instead, Radius will tell the networks which are behind the spokes are 192.168.1.0 and insert this entry to the routing table. So don't listen to the spoke. We know, you have probably an Excel somewhere where you know what are the branches, what are the prefixes behind every single branch. What we are just saying, please migrate this configuration to Radius, dump migrate Excel to Radius configuration, to local, IPv4 local parameter, and then FlexVPN will not listen what spoke is saying. It will always insert the networks as recommended by Radius. And in this way, your attacker cannot add any prefixes to your routing table on your hub. At the same time, IP verify unicast reverse path check, so URPF check to disallow traffic injection. Super safe. I mean, you are not mitigating the problem. Still, the attacker can compromise your spoke 1, but at least you are limiting the risk. Yeah? You are limiting what the attacker can do. So suddenly, attacker doesn't break your whole network, but only one of your spokes. So this is how you can use FlexVPN for that. And with that, we reached to the end. We talked already about routing protocols a little bit. I just wanted to mention, we test a lot BGP, and this is what we recommend in the big scales to the comment that was being made. we really think FlexVPN has its place in the portfolio. IoT deployments, you see the customization, you see the virtual access, which are with the parameters that are being associated dynamically from a radius. This is really unique. So if you need high customization, FlexVPN really is good for you. It works even on very small devices. This is the smallest deployment that we had. Edison, you can see the size of it. There is a router which is 5921, which is a Linux process. It's actually not a router, it's a process. You can run it on anything which is Intel, including Edison. I think Edison is that, it's EOL'd by Intel, but you can run it on everything which is Linux-based. We actually run it on ISC, and you have a full-fledged FlexVPN spoke running as a Linux process on whatever is your platform. To finish, related sessions this week. Today in the afternoon, my colleague Frederic Detienne has a session 2:30. Does it say Wednesday? It's tomorrow. I thought in the morning you said it's today. Yes. Okay, so tomorrow, crypto algorithms by Frederic, AES, GCM, CBC, quantum computer. Yeah, quite a lot of math. If you are really interested in what is going on in cryptography, please join Fred. On Friday also, Frederic is talking about IKE version 2, but protocol. So not implementation, but protocol itself, and SD-WAN security on routers today at 5 p.m. By our colleagues. So if you want to see what is going on in the SD-WAN world, session for you. I will be still available in the WebEx Teams if you want to have a chat after this session. Please complete your survey. I really appreciate you being here. I appreciate your feedback, and thank you very much for great interactive session. Thank you very much.